So ABP is used to design the what is priority register. ABP is used to, this is a communication between what and what? Interrupt controller to the what? Processor. So this is one will be modeling by what? ABP is modeling by the priority register. Are you understand? So this process will keep continuing, right? If there are interrupts on there. There is no interrupts are there. Processor will concentrate on its own job. If any interrupts are there, then it collects the interrupts one by one, address to this address to the peripherals, and then give the acknowledgement that I have served. Means I have answered the question. Did you understand this analogy? Now look at in perspective of interrupt controller. What are the inputs to the interrupt controller is? Inputs to the interrupt controller. Inputs to the interrupt controller. I am going to write in chart notation. What are the input is? What are the signals which is coming inside for any blocks? Any block diagram is nothing but inputs. What are the inputs is coming in? Interrupt active. I can write it. So interrupt active underscore I. Underscore I indicates what? Input. You don't understand. Next, what I want to do? What is next one is? Next input is interrupt to service. These are the questions you need to address, right? I can write this nothing but interrupt to be service. I can write to be service or to service is fine. Okay? Interrupt. Oh, input, right? I'm talking about input. Interrupt. See, these are input, right? Coming inside. Interrupt serviced. Interrupt serviced is the input. Now, one more input I'll take. That input, we call that is output. Call output. That output, let me write like this. This output. This output. I call this nothing but interrupt valid. Interrupt valid is the output. What is the role of this? Can you imagine what is the role of this interrupt valid?
Like flag,
If
there, then it will become one.
yeah, interrupt valid output is 1. I'm giving you valid questions to the U. Did you understand? I'm giving the valid questions to you, saying that admin is saying that if it is interrupt valid is equal to 1, I'm giving what? Valid questions to you. Did you understand? If interrupt valid is equal to 0, these are the interrupts are not valid. So I can consider this is the output. Did you understand? So then what are the outputs, sir? Let me write the outputs to this interrupt control. Outputs to interrupt controller. So what are the outputs is? What is the one output is? I can call interrupt to what? Service. Interrupt to service. Correct? Then what is another output is? Interrupt valid output. Interrupt valid output. Now for this block, how many inputs and how many outputs for interrupt control? Two inputs and two outputs. Correct. Now if I'm talking about how many questions I can take? How many questions I can take?
16.
Let us take 16. Means 15 down to 0 indicates what? 16 interrupts. 16 questions. 16 questions. To make this according, to keep this into the register, to register, what is the width of this register I can design? What is the width of this register? And what is the depth of this register is? Depth is number of, okay, I can write a number of interrupts. Number of interrupts. Number of interrupts is 16 interrupts. Means 16 questions. To store this in the priority register, what is the depth of this priority register is? 16. Correct? What is the address width of this is? 4. 3 down to 0. Did you understand this? How many questions? 16 questions. To store this in the priority register, what is the depth of this priority register is? 16. What is the width is? 4. If there are 32 questions are there, what is the priority register depth is? 32. Width is 5. Did you understand? Is it clear? Now, this is a vector of what? Now, what is the interrupt active is? It is a vector of 15 down to 0. Are you understand? 15 down to 0. What about this interrupt to service? Interrupt to service means what? Questions is given to what? Processor. So what is the width of this is nothing but question width. It is storing all this here, right? 16 questions keeping in the priority register, depth of 16. The address width of this is nothing but 4. So that what is the interrupt to service depth is nothing, vector is nothing but 3 down to 0 means what? 4. Are you understand? This is a question. Is it clear? Now coming to this interrupt service serviced. It is a signal, single, scalar, correct? It is one indicates that what? I have answered the question. Did you understand? Now what about this interrupt valid scalar or vector? It is also scalar. It is also scalar. Now did you understand out of 4 signals for what? Interrupt controller. One is nothing but interrupt active is 16, 15 down to 0. Interrupt to service is nothing but 3 down to 0. And then interrupt service is scalar and interrupt valid is nothing but scalar. These are the signals of what? Interrupt control. Correct? Now coming to the ABP protocol, we talked about these signals, right? What are the signals to this ABP? One common signal is nothing but what? P clock is the input. Another common input is nothing but what? P indicates what here? Processor, or we call protocol. Processor or protocol. Okay, generally you can take processor itself. Processor reset is the input or output? Input. Then what is the next is? Now this is I can call common signals, correct? Let us make this is common signals. Common signals. And what are the data signals, sir? Data signals are, one is what? P address. Correct? Whether input or output it is. Input. What is another input is? W data. P W data is nothing but write data is input. Right? There is another data input signal is P R data. Read data is input or output? Output. Then P write. Correct? P write. What is the P write is? If a P write is equal to 1, I should do write operation. P write is equal to 0, do the read operation. Whether it is input or output. Input. Correct? Did you understand? Then what signals we have? Control signals. Correct? Control signals. What are the control signals are? One is P enable. Is input or output? Input. What is next input? Next control signal is P ready. Correct? P ready is input or output? Output. Correct? If P enable is equal to 1.
This conference will now be recorded.
State where there is no interrupt. If there is no interrupt, what has to do? Stay remains in the same state because no interrupts are available. If there are interrupts, There are interrupts are coming from the what? Peripheral controllers. What has to do? What is the job of this interrupt controller? There are interrupts. The job of this. Now there are interrupts means I'll go to the next stage. I'll go to the next stage. Once I get there are the interrupts are there. I'll go to the next stage. So what has to do after getting the interrupts? What has to do? Now I should make this into what? According to the priority. According to the priority. Make them into according to the priority. Once I make them according to the priority, what is my next job is? That will be giving, one by one is giving to the what? Processor. Did you understand? Now, this second state mission is a state diagram is very, very crucial part of this implementation of this interrupt control. Did you understand? Now, once you answered all the questions, right? Then what we'll do? Then we'll go to the next state, interrupt service. It will check all the conditions. Then if there is no interrupts, it is go back to what? Interrupt to no interrupts, state with the interrupt, no interrupts. If still there are interrupts are there, again it go back to what? Interrupts. If I represent this behavior of this interrupt controller as a state diagram, it look like this. I am using 3 states here. Still, if you want to make this in a better way, you can include few more states. Okay. So one more state I have skipped here is nothing but error state. Error state is nothing but what? Any misbehavior is there. So I can do that so that I skip. I don't want to make this as a complex. So that first let us understand how to do this. How to do this. Then you understand that how you can again improvise your code design. If these are the consequences that there, how I can address it. Are you clear? Now here, what is the first state I'm taking is my reset state. Reset state. State with what? No interrupts. Shall I call like that? State with what? No interrupts means what? There is no questions. There is no questions. If there is no questions, I'll be in the what way? There I'll be. So interrupt active is equal to 0 means what? No questions. No questions. I'll be staying remains in the what? Same state. Did you understand? If there are interrupts, means if there are questions, what I can do? I can go to the what? Next state. I can go to the next state. Means I can write interrupt active. Interrupt active underscore I this is. Underscore I is nothing but this is the input, right? Interrupt active. Whether it is equal to 0 or not is equal to 0. Questions there means what? Not is equal to 0. Correct? If there are 2 interrupts, it may be 3 interrupts, 4 interrupts. If this condition not is equal to 0, I'll go to the what state? Next state. This state I can call state with what? Active interrupts. Shall I call like this? State with what? Active interrupts. In the active interrupts, what is my job is? Find the highest priority interrupt. Did you understand? Find the highest priority interrupt. Next, what I need to do? Making interrupt valid is equal to what? 1. What is this? Making interrupt valid is equal to 1. These are the valid questions. You should answer. Did you understand? First, I am going to finding all the highest priority interrupts. Finding all the highest priority interrupts. Then what I can do? Making interrupt valid is equal to 1. After that, what I have to do? Once I collect the interrupts, according to the priority, I have prioritized, means sorted out. Once I sorted out, then I'm making what? Making the interrupt is equal to 1 means these are the valid questions. Admin is telling that. So trainer to telling that by raising hand means he is telling these are the valid questions. You can understand like this. If trainer admin is raising the hand means until he raising the handing means what? Whatever the questions one by one is giving is valid questions. Or do you understand? Then what it has to do? What is next? Giving the highest priority peripherals to the what? Processor. This is a job done in the second state. I said these are some of the crucial part of our interrupt controller, correct? We should prioritize, making valid is equal to 1, give the questions. Highest priority peripherals to the what? Processor. Are you understand this? Next, what I have to do? Then what I'm doing? After finding the highest priority peripheral, correct? Move to the which state it is? Servicing done, or I can call it what? Interrupt given, waiting for the what? Service. Once it is giving the questions to the what? Trainer, he should be waiting, right? Getting acknowledged that whether you have answered all the questions to the students or not, admin. To check whether further I can give the questions to the what? Processor or a trainer. Did you understand? Now I'll go to the next state. After doing these three things, so we'll go to the what? Next state. What is next state is after finding the highest priority peripheral, move to the what state? Service done. I am writing here service done, or I can write what? Service interrupt given. Service interrupts given means what? I have given the questions to you. Waiting for the what? Service. You answer the question to the student and you tell me. Correct? Now I'll go to the what state? Next state. Did you understand? This is state what I can write. Service done, or I can write what? Service. Correct? Service I can write. What it will do? In this state, will make what it is making. Interrupt valid is equal to 0. Interrupt valid is equal to 0. Then highest priority peripheral is equal to what? 0. Means what these 2 points will tell? I have completed. I have given the answer to the students. Correct. So that it is making what? Valid is equal to 0. Now this highest priority peripheral 0 means what? Answered all the questions. Answered all the questions. Did you understand? This is a state I can write what? Service is done. Service is done. Now once service is done, what I have to do? Again, if there are any interrupts are there, active interrupts are there, interrupt active. If there is no interrupts, means there is no questions. What I can do? I'll go to the no interrupt service. If there are still interrupts are there, active interrupts is not is equal to 0, then what I can do? If there are interrupts are there, I can go to what? This state, active state. Did you understand? So how many states I am represented here? 3 states. Shall I use the 1 not encoding to represent this? How we can represent 1 not encoding? State at no interrupt is equal to what? 3 tick B 001. This state is what? State active interrupt is nothing but 3 tick B 010. This is nothing but state what? Service done. Done. This state what I can write? 3 tick B 1000 100. Did you understand how many states I have represented in 3 states? Now imagine each state what we are doing. The first states, if there are no interrupts, remains in the same state. If there are interrupts, go to the next state. The next states, the active interrupt active state. Interrupts are what? Making into the what? Highest priority. Then making valid is equal to 1. Then these questions are what? Giving to the what? Processor. So once it is given to the processor, it is waiting for the what? Service. Service or what? Correct? Now this state, last state, what it is doing? It is making valid is equal to 0, correct? Yeah, all peripheral questions are answered or not, it will check, correct? So once it is doing, again it is checking for any interrupts are there. If there is no interrupts, it will go to the what? No, state with what? No interrupts. Still there are interrupts are there. It will go back to, again, making a highest priority. This will be keep continuing. If you understand this state diagram, writing a program is easy. Did you understand? Are you clear? Now, first, what we can do, so we will do how to do this priority register, how to model the memory. Priority register means what? Some sort of memory, correct? We'll do this. After this, we'll go for what? Modeling the interrupt controller. To model this both the memory and the interrupt controller, I can use only one block or I can use two blocks. How many blocks I can use to do this? I can use the same block. This will be done through what? Clock of the what processor? P clock of the processor. One block is enough. First, I need to do what? Modeling the memory means priority register. Then I should go for handling the interrupts. How you are handling the interrupt means collect the interrupts from the peripherals, sorted according to the priority wise. We make valid is one and giving these questions to the what? Processor. Processor should be service to the means answer to the questions. Once it is done, it is giving the acknowledgement to the what? Interrupt controller. Saying that it is serviced. Clear? So how many signals we are using for AVP now? 8 signals. Common signal, data signals, control signals. How many signals we are using for interrupt controller? 4 signals. What are the 4 signals, sir? Interrupt active is input or output? Input. Then another input is interrupt service. This is getting from where? Processor. Then next is what? Interrupt valid is the output. Interrupt to be serviced is the output. Did you understand this? Now with this, we'll write the ports. Ports list, port list and port declaration. Then priority register modeling, read write operation. Then we go for how to handling the interrupt controller. Are you understand? So how I should start here? What I should start here first? Can you tell me from how I need to start here? Module, correct? Module. What is module name I can write? Interrupt underscore controller. Interrupt underscore controller. Now, what are the port list are? What are the port list are? Processor, priority register modeling. What are the ports are? ABB. Clock, P clock is the input. Then what? P reset is what? Input. Then what? P address is what? Input. P W data is nothing but what? Input. P R data is nothing but what? Output. Then P enable. I can write P enable, right? Then what? P ready. P ready is input or output. P enable is input or output? Input. P ready is output. P ready is output. Then what I need to write? P write. Input or output? Input. How many signals we are using for this ABB? 1, 2, 3, 4, 5, 6, 7, 8. Or I can write like this. If you are getting confusion, I'm going to write like this. These are what signals? These are ABP, ABP signals. Correct? Means what are the common signals? These are the common signals. And what are the data signals? These are the data signals. Then what are the control signals? Sir? These are the control signals. Did you understand? Now next what I need to do?
Control.
Now I should write the what? Port list for one. Interrupt control. Interrupt controller. What is interrupt controller? What are the ports for the interrupt controller is? How many ports we talked about? 4 ports. What is the port, sir?
Active.
Interrupt active. Shall I write like this? Interrupt active is an input or output port? Is an input port. Then what? Okay, let us make like this. This is input signals. Then what? Interrupt to be, shall I write like this? To be serviced. Service or serviced? Service. Okay, first let me write all the input signals. So interrupt
Service.
serviced is the input. I'm going to write the output signals. Output signals. What are the output signals is? Interrupt underscore to be service. To be serviced is the output or input?
Output.
Output. Sorry, this is comma, right? This is a comma. This is also what? Comma. Then this is also here, comma. Then what I need to write? Interrupt underscore valid. Is it input or output?
Output.
Output. Did you understand? Now this is nothing but what? Port list. These are the port list up here. This is a port list for what? APP. And these are the port list for what? Interrupt control. Now I should declare these are what are the inputs and what are the outputs. Shall I declare here itself? Like input clock. I can do that way also. Correct. I can write here input clock. Here also this is what? Input reset. This is nothing but what? Input. I can write. Now, to know what is the width, just I'm telling that this is one way you can write the port list and port declaration inside the parentheses. Correct? Now, what is the width of this? Let me remove. Let us write it here without getting confusion. What we can do, we will write it here. What are the width and what is the depth? Do you need any parameters to do this? Yes. What are the parameters? Parameter is number of interrupts. Number of interrupts. Or I can take that is nothing but depth. Is it fine? Or you understand? Depth is equal to, what is the depth I can take? Let us take 16. Then what I need to write? Parameter width. Parameter width. What is the width is? Depth is 16 means there are 16 interrupts are there. Then what is the width I can take? 4. So I can write like this dollar symbol C log 2 of what? C log 2 of what? Depth. Is it fine if I take like this? Instead of taking number of interrupts, I can take what? Depth. Then from this, I'm going to write the width. Did you understand? If depth is, there are 32 questions on there. What is the width is? 5. Are you understand? What is the next one? What I need to do? Here, what are the inputs are? Inputs. Input are what? P clock. Correct? Then what is another input is? P reset. P reset, then I'm going to write, these are the common signals. Then I'm going to write the inputs are P enable. Correct. Next, what is the next input is P, right? These are the inputs. Then what are the another inputs? Are? Input. What is the address? Address. P address is the input or output? Input. What is the vector of this? Is nothing but width minus 1 down to 0. I can write this nothing but what? Width minus 1 down to 0 of what? E address. Correct? Did you understand? Then what is the W data? W data is input or output?
Input.
Input. What is the vector of this? Is nothing but width minus 1. Correct? Width minus 1 down to 0 of what? E, W, data. These are the inputs. Are you understand? So how many signals totally? 1, 2, 3, 4, 5, 6. Now I should write the what? Output signals. Output writes P ready, right? P ready is the output. Then what is another output is? Output range of what? R data. P R data. But R data is what? Width, right? It is a width. It is same as memory modeling, right? What we did. Memory modeling. Width minus 1 R data is output. Did you understand this up to here? The signals of what? What signals these are? ABP signals. First, we'll do memory modeling. Anyway, we have listed all the signals of ABP and then interrupt controller. First, we'll do the memory modeling, then we'll go for interrupt controller. Okay. Already I have declared the port list for the interrupt controller. Later, we'll declare this is a list of the interrupt controller. Then we'll give what are the inputs and what are the output, what is the vector. That. Did you understand? Then what I need? Memory modeling means what? Reg of what? Width minus 1 colon to 0. Shall I write priority underscore reg? Is it fine? Priority underscore reg of what it is? Depth, right? Depth minus 1 down to 0. Did you understand? The memory modeling, right? Array of what? What is this? This is nothing but array of what? Vector. Array of vector is nothing but what? Memory modeling. What memory modeling we are doing is nothing but priority register. Are you understand? If any variables which we'll be using in our program will be initialized here. Did you understand? As of now, to do the memory modeling, this is fine. Correct? Now what I need to do next, how to do the memory modeling? How do the memory modeling? Always at the rate of what? Always at the rate of, let us go with positive edge of the what clock it is? T clock. T clock or pause edge of the what? T reset. Begin and end. Begin and end. What I need to do here? If, right? If my what reset is equal to 1, correct? Is equal to 1. Begin and end. And also we have else block to this. Else begin and what? End. Did you understand? Now what is my preset? If preset is equal to 1, all reg data type should be what? Is equal to 0. So period is equal to what? 0. PR data is nothing but what? Is equal to 0. Next. Memory, right? Priority. So but memory is nothing but what here? Priority underscore registers. But how to make all these to zeros? using for loop because the depth is 16, width is what? 4. This is an array of vector. So that I can go what? For of what? I is equal to 0. I is less than what? Depth or width? Depth, right? Depth, then I is equal to what? I plus 1. Priority register. Of what? Priority register of I is equal to what? Of I is equal to what? 0. Any other reg variables are here as of now? No. If there are any reg variables which we declare after going through the what? Handling of the interrupts, we will initialize here. Are you understand? Now next what I need to do? This is the end. This is the end block for what? If statement. Now else begin. The else begin what I need to write? The else begin what I need to write? If correct.
Yeah.
If P enable, right? If P enable is equal to 1, correct? Or I can write like this: P enable is 1. Begin. What I need to do? P ready. P ready is equal to what? 1. Then what I need to do? Again, I need to write what? If condition. Correct? What is if condition is? If P right is equal to 1, or I can write like this also, right? P right is equal to P right begin, and then let me write the end. What I want to do here? Priority register, right? Priority register of what? Of P address. P address. This is equal to what? PW data. Did you understand? Else, what I can do? Else. So there is single statements are there. So I can remove this, right? Shall I remove this one here also? Else. Else. I can write here. Else. PR data. PR data, correct, is equal to what? Priority reg of what? E address of I. Correct. So what we are doing is nothing but preset is equal to 1. We are making all reg data types to what? Zeros. Else, if preset is equal to 0 is nothing but this else for the preset is equal to 0. Else, now I should do write operation and read operation, right? Write operation and read operation. To do the write operation, read operation, first I need to do the handshaking. How to do handshaking is nothing but if enable is equal to 1. If enable is equal to 1 and P ready is equal to what? 1. And then I'm checking if P write enable is equal to what? It is 1. Correct? If it is 1, what I'm doing? Write operation. Else what I'm doing? Read operation. Correct? Then again what I need to do? End. Again I need to write the else to this, right? What is else to this is nothing. Else, what I can write? P ready is equal to what? 0. Did you understand? Else P ready is equal to what? 0. Now this is the end for what I can do. This is the end for what? This else. Then what I need to do? Then in the what? Always. Are you understanding this? Memory modeling? Do you have any questions here regarding this? So always at the positive edge of the clock and preset. If preset is equal to 1, range data type should be zeros. Else, if preset is equal to 0, I'm checking if p enable is equal to 1. If p enable is equal to 1, if p ready is equal to 1, then what I'm doing? I'm checking if my write enable is equal to what? 1. If write enable is equal to 1, what I'm doing? Write the data. Correct? Write the data to the what? Priority register. Else, what I'm doing? Else means this priority goes what? Is equal to 0. Then I'm doing what operation? Read operation. Then I'm going to end this. This will do if enable is equal to what? 1. Correct? If enable is equal to 0, p ready is equal to 0. Did you understand? Or if I write here, this is also fine. P enable input is equal to 1. If this is true, it is going to this operation. Else, if P enable is equal to 0, P ready is equal to 1. 0. P ready is 0 means what? Or it says when P ready is 0 means what? No handshaking, right? No like handshaking, there is no transaction. Are you understand? Now this is nothing but what? Our memory model, priority register model. And this is n for the cells and this n for the this always plus. But in the same clock, right? The same clock we are doing what? The same clock we are doing what? Interrupt controller also. Are you understand? Now coming to the interrupt controller. Now are you done with the ABP means processor priority register modeling? Now coming to this interrupt controller. The interrupt controller, now I need to use the parameters. What parameters is? What state representation? What is state representation is? Parameter, correct? State with what? No INTR I'm going to write. This indicates what? No interrupts. This is equal to what? 3 tick B 001 I can use. 1 not encoding. Next is what? Parameter interrupt active, right? Active underscore what? Interrupt is equal to what? 3 tick B 010. Correct? Next parameter. State with what? Interrupts to be served, or I can use the interrupt service done. Correct? According to, shall I go according to this? Whatever the state diagram I was represented here. Shall I go like this? Interrupt, active interrupts. This is a state with the active interrupts. This is what? Service is done. What is service is done? I can write this is nothing but interrupt service. Service underscore what I can write. Done. Is it fine? This is 3 tick B100. 3 tick B100. Parameter declaration for the watts. So this is nothing but interrupt states. Are you understand this? Next, what I need to do? Port declaration. The port declaration of the what? Interrupt controller. How many ports we are using to model this? 4 ports. One is interrupt active, another one is interrupt service, and another is interrupt to be serviced, another is interrupt valid. Now you tell me here, let us write it here. Give the spaces and write it here. What are the inputs to interrupt controller is? Input, correct? Interrupt underscore, correct? Active, but It should be what? Vector. Interrupt means what? Interrupts means what? Questions, right? Up to interrupts means question means. What is this? Is vector of this is nothing but depth minus. So depth indicates what here? I'm writing in my case is depth indicates number of interrupts. Are you understand? 16 questions. Next, what is another input is? What is another input is? Interrupt serviced. It is scalar or vector? Scalar is the input. Next, what is the output, sir? Let us write it here. Let us write it here. Output, rich, interrupt, what? Interrupt to be serviced. Is it vector or scalar it is? Vector. Vector of what it is? Width minus, right? Width minus 1 down to 0. Or you understand? Next, what is another output is? Output, rich, interrupt, correct? Interrupt what? Valid. Is it scalar or vector? Scalar. Are you understand? Now we're done with the port declaration of the what? Interrupts. Did you understand? Now we'll understand how to modeling, how to handling the interrupt controller. So what I have to do to handling the interrupt controller? Always at the what? Pause edge of the what? T clock. T clock. Begin. Same clock I can use, right? For both the process, I can use what? Memory modeling, priority register modeling, and then handling the interrupts. Same clock. Always at the pause edge of the clock. Now what I need to do here? I have a states, right? I have represent the behavior of the interrupt controller. I have represented the what? State diagram. But this has to done through what? If my preset, correct? Preset is equal to 0 or not is equal to 1. Both are same. Is equal to 0 or not is equal to 1. Then begin. Begin and end. Here what I need to do in this? If preset is equal to 0, states. To write the state, I can use what? Case statement. Case of state, present state and the next state. Then I can use what? End case. So I'm using state here, so that I need to declare this. So what I can declare here? First, I need to declare the integer of I, because since I'm using I, correct? Integer of I. Next, what I need to do? Rich. So I am using here. You can see this is my for loop. I'm using so that I'm declaring integer I. Next, what I need to do? State. State is a vector or scalar. To represent the states, how many bits we are using? 1 or 10 coding? 0, 0, 1, 0, 1, 0. 2 down to 0 is nothing but 2 down to 0 of what? State. Also, I need a next state. Let us write like this. 2 down to 0 state and 1. Next state. Are you understand? Now, let us go to here. Now, case state. Case state. What is the first state is? Yes, with what? State with what? No interrupt. Colon, begin and end. What happens in this state is? What happens in this state is? Now I need to check, right? If of what? Interrupt. Interrupt active is equal to or not is equal to? Not equal to what? 0, begin, correct? Begin. What is my next state is? Next state is nothing but, I should go to the next state, is nothing but what? Service with what? State with what? Active interrupt. Active interrupt. Did you understand? So then end here. Then what I need to do? Else, which state I can go? Same state. So next state is equal to what? Yes with what? No interrupt. This is a first state. Then I'm going to write end here. If there are interrupts, I can go to the what? Next state. If there is no interrupts, state remains in the same state. Now, the very crucial part here is nothing but state with the what? Active state, active interrupts. State with the what? Active interrupts. In the state with the active interrupts, what is the process we need to do? Once I get the what? Interrupts, I should assign the prioritize. Correct? Now we should understand that how you can do that. How you can do that. Now let us show you the Excel sheet. Okay, we'll understand how to do this. Okay, now if you look at this, the first one is nothing but peripheral name means what? Interrupts. Interrupts, questions. Correct? Questions, how many questions I'm taking? 16. I can write 0, 1, 2, 3, so on up to 15. Did you understand this? Interrupts. Interrupts name is nothing but 0 to 15. Means 16 questions. Now, what is this? Priority value indicates what? Priority value means trainer is telling to the admin that student number 0 is 10 priority. Student number 1 is second priority. Student number 3 is, student number 1 is 2, again 5, 4, 6, 8, 19, so on. This is randomly given, not in order. This is what in your test case, what you are going to do. All these questions, interrupts, you are assigning a random. 1, 2, 3, 4, 5, 6. Then are you giving 15, 14, 12, 13? Different test cases we are going to write. Now I am giving what is the parity value is nothing but it is an order or it is a random. Random. Now what is the job of this state is? Priority. You should make the questions into the what? Priority. When it is making the priority, again it has to check that the student raising the hand, but he is having a question. Student raising the hand, but there is no question. Correct? Now here 1 indicates what? Interrupt is raised. 0 indicates what? No question is raised. No question is there. Did you understand? Now look at this. This is 1, correct? The peripheral name 1 is what? Interrupt is raised. And 4 is what? Raised. And the next is what? 9 is raised. 11 is raised. 13 is raised. Again 14 is no. 15 is also no. Did you understand? Now what I need to do next is, after servicing this, once he raise the hand and asking the question, after giving the answer, the service is done. Correct? Service is done. Now after giving the service, what we are doing? We are making to what? 0. Yeah, for all this we are making to what? 0, 0, 0. The question comes here, how to select the highest priority here? How to select the highest priority? How to select the highest priority? Now look at this. This is my peripheral names 0, 1, 2, 3, 4 up to so on 15. These are priority values. Now you tell me in this 0 to 15, which one is highest priority? Is 13? I should see only the what? Who is raising the interrupts or who is not raising the interrupts also I should see. Only the what? Who is raising the what? Interrupt. This is a 1. Interrupt name is what? 1. Its value is what? 2. Interrupt name is what? 4. Its value is what? 6. Next interrupt value is nothing but what? 9. Its value is what? 15. Next interrupt name is what? 11. Its value is what? 14. Interrupt name is 13. Its value is 32. He raised. And 14 and 15 is not raised. Now I should concentrate what? You are raised. Right? You are raised. Now which one is highest priority first is? Huh? 13. The 13, what is its priority value is? 32. Now I should give the priority to this one, 13. Once I done this, what I'm making? 0. Making flag to what? 0. Did you understand? Next, which one I need to prioritize after this 13? Is it 8? So 8 does not have a what? He is not raised the interrupt. He is not raised the interrupt. Correct. Now you can look at this. Is it 9? Correct. 9. Who is the priority value is 15. He raised it. Right? First is 13. First interrupt to be service is what? 13. What is the name of the peripheral name of this is nothing but? Peripheral name is 13. Correct? But this interrupt I need to give the service first. Second, which peripheral name I need to give the service is? 9. Its value is nothing but what? Second interrupt. Okay, let us check the 15. Okay, sorry. 15 also, let us consider 15 also 1 is there. 15 also 1 is there. No, tell me, let me know. Here, 1 is away raised. Interrupt name 1 is raised. Interrupt name 4 is raised. Interrupt name 9 is raised. 11 is raised. 13 is raised. 15 is what? Raised here. So now I should give the interrupt name. First interrupt I should give to this one because highest priority 32. Now for this interrupt name I need to give the service first. Did you understand? Next, which one I need to give the service is 15 because after 32, 19 is the what? ISS. But 24 here, you can see 24, 22 are also what? Greater than the 19, but they have not raised the what? Interrupts, raise the question. So that 15, its value is nothing but 19, correct? The second is nothing but 15 for the interrupt service. Second interrupt of the service is nothing but what? 15. Next one?
9.
Next one is 9, which value is 15. So next one? 11. 11 is 14. Correct? Next one? 4. Correct? Next one is 4. 4. Next is what? Next is 1. First, which interrupt I need to service? Interrupt name is 13, 15, 9, 11, 4 and 1. Are you understand? Once I give the service, right? After service, interrupts goes what? Low. After giving the service, this goes what? Low. I'm making all this to what? Low. Did you understand? So here, what is the highest priority value is nothing but? What is highest priority value is nothing but? How we are doing is nothing but. First, we will take this. This is raised. We will take this value and we'll compare with this. 2 is less than 6. Correct? And then you will take this value. Now we understand 2 is less than 6. The highest parity is 6 now. Presently it is 6. Next, what I am doing? Comparing 6 with what? 15. In this case, 15 is what? Highest parity. 15 is greater than 6. Next, what I need to do? Now here 15 is greater than 6. Then what I need to do? Then again I go to here. First I am checking this with this. From this I'll get the highest priority value. Now I'll go here. I'll check this. Then I'll go here. Correct? I'll check this. Again, so on. It goes here, again goes here, again goes here. Did you understand? Now from this is nothing but my highest priority value. 2, 6, 15, 14, 32, 19 are the priority values, highest priority values. And what is highest priority peripheral here? Name of the what? Peripheral name. Name is what? 1, 4, 9, 11, 13, and 15. Can you write the logic to this? You take this as an algorithm. Okay. What is the second state job is to do? Based upon the interrupts, parity, it has to sorting out what? It has to sorting out which one it comes the first. How to write a logic to this one? How to write the logic to this one? Can you imagine, can you rethink how to develop a program to this? How to develop a program to this? If you've done this, almost you are able to complete the what? Interrupt controller. This one, where I need to do, which state I need to do?
What size?
Second state, right? In this state, next state, I am going to write what? State active interrupts. Begin, right? And end. What I need to do in this case is, let me show you this diagram. In the state active interrupts, finding the highest priority interrupts. Making the interrupt valid is equal to what? 1. Giving the highest priority to the what? Peripheral to the process. Can you write the logic to this? How to write the logic to this? Using for loop, correct? I can write what? For I is equal to what? 0. Then what I need to do? I is less than what? Depth. Then I is equal to what? I plus 1. Begin and end. Now I'm going to what? All the peripheral names, all the peripheral means what? 0, 1, 2, 3, 4, up to sound what? 15. Correct, 0 to 15.
Now from this.
Here what I need to do?
Where the interrupt is active.
First priority. So how to do? I can write if what I can write? Interrupt active, I of I. I can write interrupt active of I. This is what? Is equal to 1. Is equal to 1. Then what I need to do? Begin. Here what I need to do? Now I should write highest underscore highest priority. So let's take the value. Highest priority value is equal to what? How to take the highest priority value? Priority underscore range of what? I. Did you understand? After this, what I can do? Highest priority of what? Peripheral. Peripheral, let us like this. Peripheral is equal to what? Now here I am going through all the peripheral names 0, 1, 2, 3. For loop I am using. While going through the for loop, what I am doing? Interrupt active of I. If interrupt active of I, first iteration I is equal to 0. Correct. If this is equal to 0, then it is going out of this if. Correct. If it is equal to 1, what I am doing? Highest priority value is equal to assigning the what? Priority of the register of I. And then highest priority peripheral is equal to what? Highest priority peripheral is equal to what? Is equal to I. Did you understand? Now to check this, what I need to do, I need to write like this. If flag, if flag is equal to 1, if flag is equal to 1, begin. Then once I do this, after checking this highest priority, what I need to do? Flag to what? 0. Let us make flag to what? 0. Then I'm going to end this. Are you understand? Else begin, what I want to do? Else begin end. Here what I need to do? If of what? If of highest priority value, this is nothing but value is what? Less than what? Priority. Wedge of what? I begin. Then what I need to do? If it is less than, what I need to do? Highest priority value is equal to what? Priority register of what? I. Register of I. Next, what I need to do? Highest priority peripheral is equal to what? I. Is equal to I. Then what I need to do? End this. Then end this else. End the else. Correct? Now what I need to do? Then end this. Now this is the logic where you are going to what? Getting all the interrupts which having the what? Highest priority. Or you understand? Then what I need to do? What I need to do after this? Now what we did in this case is nothing but finding the highest priority interrupts. Then what I need to do? Make the valid is equal to 1. Then what I need to do? Give the highest priority peripheral to the what? Processor. Did you understand? How to do this then? This is a program we did. Correct. Next, what I need to do here? What I need to do? Interrupt, correct? Valid. Interrupt valid is equal to what? Is equal to 1. Next, what I need to do? Interrupt to be serviced is equal to what? Highest peripheral. Highest peripheral. Did you understand? After this, what I need to do? You can make flag to what? Flag is equal to 0. Whether I need to do flag 0 or 1.
Flag operation once explained.
Okay. Let me explain the flag operation. Let us coming to here. All this is my interrupt names 0 to 15. This is a random interrupt value. Interrupt value. Now in this case, I need to what? Starting out the interrupt which is having a highest priority. Highest priority. Now this is zeros ones indicates here what it is. Interrupt raised. So interrupt raised. So here interrupt name 1, 4, again 9, 11, 13 and 15 will be raised here. We need to concentrate on only what? These interrupts, not on what? Was not raised the interrupt. You don't understand. Now, how you can first how you can make the highest priority? How you can make the highest priority? Now you will take this value, correct? So how to go through this complete loop is nothing but for I is equal to 0, I is less than depth, and then increment. While going through, what you are going to do is nothing but we'll be selecting this value. So first, this will be dropped, right? So what we are doing in the case is nothing but, if my interrupt active I of what? What is interrupt active I of 0 means what? If iteration, first iteration, 0 means what? This is a 1, right? This is a 1. His flag is not, it is not raised. So I'm not selecting that interrupt active. Correct? Only when this is equal to 1, I'm selecting. Did you understand? Now here, this is a 1, I'm selecting this. Now first what I have to do, I have to take this value. This value, what I need to do? What I'm doing in this case, you understand this piece of code here. I'm taking highest priority value is equal to what? Now this has to go if what? If flag is equal to 1. If flag is equal to 1, I'm going to this. Highest priority value is equal to what? Priority of the register of I. What is the priority of the register of I is nothing but. Now this is nothing but 2, right? What is the priority register of I? This is nothing but memory indexing, right? I'm taking the memory index. What is the priority register is? Depth is 16. Width is how much? 4. 3 down to 0 means 4. A priority of register of I0 means what? It will get the what? First one. 1 means second one. 2 means what? 0, 1, 2, so on. Here, if this interrupt active is equal to 1 only, I'm going to this. Again, here I'm checking if flag is equal to 1. I'm doing this. Highest priority value is equal to what? Priority register of I. Now, what is the value of this is, you tell me? 2. Now, what I'm doing here? Highest priority peripheral is nothing but what now? Is nothing but 1. In this case here, this highest priority value, I value I'm assigning to the what? Highest priority. Now that is nothing but 1. If this is equal, this is 1. This will be assigning to the what? Highest priority value. Then what is highest priority value as of now? Correct? First iteration, this is equal to 1. Correct? Then what I'm doing? I'm making this flag to what? 0. Now I'm making this flag to what? 0. Did you understand? Next, what I need to do after this? Again, compare, right? Flag making to 0. Again, what if flag is equal to, if flag is equal to 0, now I'm making flag is equal to 0. Again, else begin, what I'm doing here? Highest priority value. What is highest priority value is this now? 2. 2 is what I'm doing. Less than the priority register of I. What is the priority register of I? This is coming to the now else block. What is next value is nothing but. This is 6. 2 is less than 6. Is this condition is true? 2 is? It is true, right? 2 is less than 6. It is true. Well, once it is true, what I'm doing? Highest priority value is equal to what? Priority of the register. Now, what is this value is nothing but 6. Now, what is this value is nothing but its index value, right? What is its index value is nothing but 4. Now, highest parity peripheral is nothing but what? 4. Did you understand? Again, what it is going to do? Now it will take the same value, 6. Comparing with what? Next value. What is next value is? Here, next value is nothing but it will go here, this value. But in this case, 15 is greater than 6. 15 is greater than 6. What happens in this case? 15 is highest priority. Index value is nothing but what? 9. What happens in this case here? You can understand. What will happen here? 15 is, now its value is what? 6. Its value now, what is the priority value is nothing but 6 or 15 here? 15. 15 is less than 6. False. Then it won't go here, right? Again, what happens here? Again, it will go to the next value. What is next value is nothing but. Next value is 14. 14, it is comparing with the what? Now it is 6. 6 is less than 14, right? Or you understand? Now it will take its value and it's the index value of the peripheral name. Similarly, what it is going to do here? Like this, it is keep comparing and gets the what? Highest priority peripheral. Or you understand? Did you understand this logic here? Now, once you get all the what? Highest priority values, now what you are doing? Interrupt value is equal to 1. Now this will be giving to the what? Processor, right? Now what I need to do, interrupt to be service is equal to what? Highest priority peripherals. Then what I need to do, after doing this, I can make to what? Flag to 0. Flag will becomes 0 once this will be serviced. Once this will be interrupt is raised here. Now it is flag is equal to 1. After service, interrupt goes to what? 0. Are you understanding?
Service completed.
Yeah, once service is completed, then flag becomes what? 0. Now this is what? After service, interrupt goes what here? Low. Okay, first in this program, what we have done is nothing but we are taking this value. And we start comparing with what? Who is raised the what? Interrupt. If it is less than, right? If it is less than, we are taking this value. Again, we are comparing. Again, we are comparing. Again, we are comparing. Again, we are comparing. Are you understand? Now, once we will get all the highest priority peripherals, then we need to do this. Is it clear? Next, what I need to do? What is next state is? What is next state is nothing but. This is nothing. Service with what? Yes, with what? Service done. Service done. Begin and end. In this state, what I need to do? This state A. Interrupt is what? Serviced. Correct. If interrupt is serviced, begin. What I want to do? In this case, if it is serviced, what we need to do? Interrupt valid is equal to what? 0. Interrupt valid is equal to 0. Next, what I need to do? Interrupt, correct? Highest. Highest peripheral, what I need to do? Peripheral, this makes to what? 0. This makes to 0. Next, what I need to do? Highest interrupt value also makes to what? Is equal to 0. Did you understand? You make all this to what? Zeros. Once it will be service is done. Are you clear? Next, after this, what I need to do? Reset state, right? Again, I need to check else or if statement here. If statement. If what I want to do? Interrupt active not equal to 0. Begin. What is my next state is? What is the next state is? Next state is equal to active state, right? State with what? Active. Then again, in this case, make what? Flag to 0. Else, which state it is go? Next state is nothing but state with what? No interrupt. Did you understand? Now I should end here. This is the end. And then here I have ended this one if, and this will be ended here, and this will be ended here. Okay. Then end case. Then end the what? End the what are the end I need to do? End the if, then end the always. So then what I need to do? Next, what I need to do? Always, correct? Always at the rate of passage of the clock, correct? Begin or passage of the clock or state, next state, right? Next state. What I need to do? State is equal to what? Next state. State is equal to next state. Then what I need to do? In the module. So in this complete handling of the interrupts, the crucial part you can see is this is the one, right? How you are prioritizing the highest priority. Okay, you can not only this logic, you can write other logic also. Not only using for and if condition, you can use any other logic. What you have to do once you get the interrupts, you need to what? Making it what? Prioritize. Then that will be assigned, that will be given to the what? Processor. Are you understand? You can think of any other logic you can able to build it, this one. Second state, this is what we are writing. If validity is equal to 1, service to be, interrupt to be serviced is equal to highest priority peripheral. Yeah, after this, what I need to do? Next state I should write. Next state where it will go. Next state is equal to service with what? State with service is done. This state it will go. Did you understand? So this is what the complete design file for interrupt control. Then how to write the test bench to this? Can you write the test bench to this? Did you understand? Now I need to write the test bench to this. Write the tb.v. Okay, let us modify this one because I'm using the ports here. First, I need to include. Tick include. There is nothing but interrupt controller. File name is interrupt controller.v. Now this is my module. Let us make it here. Module TB. And here this is nothing but what? Let us remove this. Okay, let us do first instantiation. Then I'm going to copy the same signals. Then I'm indicating the ports which are input port and output port. So module instantiation is nothing but module name DUT, correct? Now let us remove this. Now shall I go with what? Shall I go with port by name? Then this is dot P reset. Then let us go to the next one is this is a dot P address of what? P address. Then dot. Okay, let us do this part of program. Okay. technical issues. EW data. Again, data. ER data. Data P enable. P enable. This is data P ready. This is data P write. Data interrupt active and data interrupt service. This data of interrupt to the service. Yeah, this is a data. Interrupt valid. Now in my design file, I am using some variables right here. What variables I was using is IS parity peripheral, IS parity value. Any other variables I'm using? Flag I'm using. Flag I'm using. So I need to declare this first. So what is the flag? Is scalar or vector? Reg flag. I can use reg flag. Then reg, what I am using is IS parity. This is vector of scalar. Vector, right? Vector of what it is, nothing but width minus 1, right? Width minus 1 down to 0. Again, what is the peripheral? Highest peripheral? Reg. This highest peripheral is a vector of scalar. This is also vector of what? Depth or width? So highest parity peripheral is a depth or width? Depth. Highest parity value is width minus 1. Correct? This is what? Depth minus 1 down to what? 0. Okay, let me show this one. You can tell me. Highest parity value is depth or it will be width. Highest parity peripheral is nothing but it is what? Width minus 1. Width minus 1 means what? 3 down to 0. Correct. What about this highest parity value is? These are the parity values. It is randomly assigned. Randomly assigned. So what is the vector to this is? This is a width or depth I can use. Depth minus 1. This I can use as a what? Depth minus 1. Depth minus 1. So any other variables I'm using? No, correct? Then if my preset is equal to 1, all the reg data type I should make it what? Zeros. Then what are the variables I make it zeros here? Here. Can you tell me what are the variables I can make it? State next state, right? What is state is equal to? What I can write? Instead of 0, I can write like this. State with what? No interrupt. Next state. No interrupt. The state with what? No interrupt. Next. Highest. Peripheral is equal to what? 0. Then what? Highest value is equal to what? 0.
Flag equals to 0.
Flag is equal to 0, correct. Then I can make what? Flag is equal to 0. Did you understand? I'm declaring all the reg data type to what? Here it is zeros. Now let us coming to this test bench. So this is nothing but port by name connection. Port by name connection. Now I should declare depth is required here. In the test bench, depth is required, width is required, and this parameters is required. And this I need to change into what? Inputs are changing to the what? Reg data type. So whatever the necessary I need, I'll keep it here, and that else I'm going to remove. Correct. Inputs are reg here. Here it is reg. Here it is reg. And then there is nothing but what? Void. Here this is nothing but void. Void. Next. So these are the variables. It is also input signal, port signals. These are void data type. And this is a void data. Void data type. Then all these are reg data types. Correct. So this is not required. This is a design part of program. Let us remove this complete program. Okay. Now this is a model instantiation. So this will be done after what? After the declaration of the ports. Now I'm going to write it here. There's nothing but port declaration. If you understand, inputs are changing into reg data type, outputs are making into that by data type. So I'm keeping these parameters. If I'm using, I'll be keep it. If I'm not using, I'll remove this one. Correct. Now what is next step I need to do? Clock generation. Always begin, correct. Always begin what I need to do. Clock is equal to what clock? P clock is equal to 0. So let us make hash 5. Okay. P clock is equal to 1. Hash 5. Then end this. Correct. Next, what I need to do? Initial begin and end.
Sir,
Begin and
hash
end.
5.
Okay, this is nothing but hash. Initial begin and end, what I need to do? If my preset, right? Preset is equal to what? 1. Next, what I need to do? If my preset is equal to 1, all my reg data type becomes what? Zeros. Correct. Next, what I need to do? Let me introduce the relay. Repeat up to at what? Passage of the clock. Then begin and end. Begin and end. What I want to do? P reset, correct? P reset is equal to what? 0. Then what I need to do? First, write operation. Correct? So how to do write operation? We need to write the task for the write operation. So already we have done this, right? Already we have done. Let us copy the same. So let me copy the same. This is a task. For the write task. How many input arguments I'm using is 2 input arguments. Always at the pass P clock, what I'm doing? If write enable is equal to 1, P address is equal to what? Address. This is an argument I'm passing here. And then W data is equal to what? Priority data. What is the data I'm passing here? Priority data. And then P enable is equal to what? 1. And wait and ready is equal to what? 0. This is what a write operation, right? Memory modeling, if you remember. Always at the positive edge of the clock. After this, I'm making what? All these are making to what? Zeros. Now let us copy the same. Just copy the same here. So I'm going to keep it here. Keep it here. Then I'm going to call this task. How to call this task is write up, but I need to use what? For loop, right? For, let us use j is equal to 0. J is less than what? Depth. And then j is equal to what? J plus. And then begin. What I need to do? Call the task. Write off what? Write off. What is the argument I'm passing is address and priority date. So let us pass I comma I first. If I pass I comma I, what happens here? What happens here? This is a task we are writing for the write operation. Okay. If I'm passing I comma I, what happens? For loop I'm using. Sorry, j. Sorry, this is not I. J comma j. Let us use j comma j. So when j is equal to 0, what happens? What is address is? 0.
Yeah.
What is this priority data is also? 0. For 0, it is 0. Again, this loop iterates. 1, 1, correct? 1, 1, again 2, 2, 3, 3, 4, 4, so on. Or you understand? This for what operation is write operation. After doing the write operation, what I need to do? How to handling the interrupts. Now I should pass interrupt. Interrupt active is equal to what? Interrupt active is equal to dollar symbol what? Random. Randomly I'm giving the interrupts. So after this, I'm going to give some delay. Let us give some delay. Then I'm going to finish this. Finish this. Now this is peripheral controller handling here, correct? What peripheral controller will do? It gives the interrupts, right? Interrupts active is equal to what interrupts I'm taking is random interrupts. Now I need to model the what? Now complete interrupt controller is modeling in the what file? In the design file. This is how we are designed, correct? Then peripheral modeling is done here. Job of the peripheral is to gives the what? Interrupts. Random interrupts I'm taking. Now you should model the what? Processor. How to model the processor? How to model the processor? So to model the processor, I can use this one. Processor modeling is always at the pause of the clock. What is this is? Interrupt to be serviced. If it is not is equal to 0, what I have to do? Let us give some delay. Then interrupt active is equal to off. Interrupt to be serviced is equal to 0. Then if interrupt service is equal to 1, then I'm giving delay. Then after that, I'm giving what? Interrupt service is equal to 0. So this is the process of what? Processing the what? Processor modeling this is. Are you understand? What is the job of the processor modeling here? It will take the what? Takes the interrupts from the where? Interrupt controller. Once it gives the addressing that, then what it is going to do? Service is equal to 1 to the what? Interrupt controller. This is what we are doing. Always at the passage of the clock, what we are doing? If interrupt to be serviced is not is equal to 0. Correct? If interrupt to be serviced is not is equal to 0, what we are doing is, we are taking the what? This is nothing but question, right? Interrupt active is nothing but question of what? interrupt to be serviced, which question I need to give? Did you understand? This is equal to 0. Then I'm saying that what? Interrupt service is equal to 1. It has to keep repeat, right? It has to keep repeat. If there are still questions are there, processor need to what? Answer. Then I'm giving delay. Some delay I'll give. Then after that I'm making what? Interrupt service is equal to 0. Are you understand? This is what my processor modeling it is. Now these are where I'm doing what modeling it is. Peripheral modeling. What is the job of the peripheral modeling is nothing but it will give the interrupts. So I'm taking interrupts underscore active I is equal to what? Random interrupts. Did you understand? So in the test bench, what we did, so we included the design file, then parameter initialization, then inputs are rich data type, outputs are Y data type. Then this is not required right now. When you use the test cases, I can go for this. Okay. This is nothing but my port declaration. This is a port declaration. Then this is a one way to clock generation. Initially, P clock is equal to 0. Reset is equal to 1. Let me tell you what is this use of this reset. Okay, later I'll tell you. Now I'm introducing the delay here. Then what is my reset is equal to 0. So here, okay, let us remove this one. Let me do only one time. And after that, we'll go for how to do it. We'll see later. Now I'm using the for. So I to 0 to what? Depth. Then write. What I'm doing here is nothing but let us make this is j only. Sorry, I only. Since I'm using I variable here, I only. Did you understand? Now write I comma I and then end. Then I'm interrupt is generated here. Peripheral modeling is done here. Then I'm finishing this. Then this is the process of what? Process modeling. This is a process modeling. This is processor modeling. Then what I'm doing? This is a task for what? Write data. Did you understand? This is a write data. This is the end task. Now I'm writing the reset task. This is a processor modeling. What processor will do? What is the job of the processor is it will take the question from the where? From the interrupts. What is the input to the processor now? Processor interrupts to be serviced. It will take that questions and then answering. Once it is answering, saying that what? Interrupt is serviced. Saying that by making interrupt service is equal to 1. 1 indicates what to the interrupt controller is. Interrupt is serviced. This is what we are doing here. Always at the positive edge of the clock. If interrupt to be serviced is what? Not is equal to 0 means what? Not is equal to 0 means 1, it should be 1. If this is 1, what I am doing? After some delay, interrupt underscore active is nothing but what? Interrupts. Interrupts underscore active means what? Interrupts of what? Whatever the question I need to answer. Interrupt to be serviced. Now I'm making to what? Is equal to 0. Means I have given the answer. Correct. Then what I need to do? Interrupt service is equal to 1. Did you understand? Again, after some delay, what I'm going to do? Interrupt service is equal to 0. Or you understand? Now this is for processor modeling technique. Now this is the task for what? Reset. This is very simple. What is the use of this reset task is? You can say I'm writing the reset with no arguments. Task with the no arguments. The task name is reset. What I'm doing here? All the inputs, right? All the inputs, what I'm doing? Putting 0, right? P enable, P write, address, data, interrupt active, then interrupt service. Then this I'm taking priority array. I'm making what? Here it is zeros. So this I'm calling after my reset is equal to 1. After this, I'm going to call this task. Now what happens here? When reset is equal to 1, all these variables should be what? Zeros. That I am calling as what? Reset it also. That's it. Did you understand this? Are you clear? This is what one test case I can say. Now I'm calling here, it is happening, right? I comma I means what happens here? When I is equal to 0, what is data of this is nothing but 0. When I is equal to 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, so on, 15 to 15. Did you understand this? Now let us look at again the design file here. This is our interrupt controller. These are the ports. These are the ports for what? ABP ports. These are the ports for what? Interrupt controller. These are parameter we declared. Now we are declaring input and output ports. Correct? And this is nothing but what? Interrupt control signals. This is nothing but what? These are data types what we are using. These are data types. In always, if reset is equal to 1, all reg data type is making to 0. If reset is equal to 1, in design file I'm talking about, correct? Then else begin, this is for what operation it is, up to here. Memory modeling, correct? If enable is equal to 1, read enable is equal to, ready is equal to 1, we are writing the operation. If write enable is equal to 1, write the data. Then else what? Read the data. If enable is 0, what we are doing? Ready is equal to 0. Did you understand? This is nothing but what modeling is? Memory modeling. Now this is what we are doing. In this case is nothing but interrupt controller. So always at the pulse edge of the clock, if reset is equal to 0 or not is equal to 0, then I'm using state diagram. So that I'm using the case state. First is what? State with no interrupts. In this case, interrupt active is not is equal to 0, where it is going to the next state. Else it is going to staying in the same state by keeping flag is equal to 1. In the next state, this is nothing but what? Active state. In the active state, what we are doing? We are making according to the what? Priority. So for this, I'm using for then interrupt active I is equal to 1. Then I'm checking the flag. If flag is equal to 1, I'm doing this. Else, I'm doing this. And once I get all the priorities, then what I'm doing? Interrupt valid is equal to 1. Interrupt to be serviced is equal to what? Highest priority peripheral. Then I'm going to the next state. So this next state I'm representing as state with the interrupt is serviced. In what I'm writing is service is done. Correct. Again in service, interrupt service is done. In this case, what we are doing? We are checking if interrupt service is equal to 1. If this is equal to 1, what I am doing? Valid is equal to 0. Interrupt served to be served is equal to 0. Peripheral, highest peripheral is equal to 0. Priority value is equal to 0. Else, if my interrupts active is not is equal to 0, I'll go to this state, making flag to 1, and or else I'll go to this state. Then I'm going to end the case. Then always next state is equal to next state. Now here I'm taking only one test case. One test case. Let us run this program and tell you. Now you can see here, this is my P address. This is my what? W data. Read and write is happened here. Read and write is happened here. Correct. Let us make this both this into unsigned. Okay, unsigned. Okay, the changes what I have done in this program is not saved. Let us save this one first. Save this. Again, I'm going to run. Now you can see this is my W data and then address. This address I0 J0, right? Right, I0 J0. I'm writing 0 0 1 1 2 2 3 3 4 4. Now what my interrupt controller will do? Let us make this. Which one is give the highest priority? Now interrupt active. I'm making as a dollar symbol random. Dollar symbol random. So now we look at this. Which one is served first? Which interrupt is serving? Let us make this both values are in unsigned format. Which one is giving highest priority here? It is 13, right? In 13, what is my interrupt valid is nothing but 1. And then interrupt peripheral, highest peripheral is nothing but what? 13. So next what it is giving the priority is 12. Next it is 10, 8, 5, 2. Did you understand this? See, I have given this interrupt active. This interrupt active, let us make this into the unsigned format. Unsigned format. What is my interrupt active at this point is 13, right? This is 13, this is a 12, 10, 8, 5, 2. Now this is giving according to the what? Priority. Correct? In this case, if I'm going to change, if I change, okay. In this case, what is the right operation? Earlier case, I was using I, comma I. Now I'm using depth minus 1. First, I is equal to 0. What is depth is 16. 16 minus 1 is nothing but 15. For 0, it is 15 now. For 1, again, it is 14. So on. In this case, what happened is, this is what happened. The test case, read write is happening what? The data will be what? Same. 0, 1, 2, 3, 4, 5, 6, 7, so on up to 15. Up to 15. Correct. Now, if I'm going to change like this, now this is how it is assigning the parity. Correct. First is 13. Then 12, then 10, 8, 5, and 0. Now I'll do the small changes here. The another test case, what I can do is nothing but I can make depth minus. Depth minus. Now in this case, what happened? How it will be solved? Which one gives the highest priority? No, reverse of this, right? Reverse of what? Whatever you're getting earlier. First is 13, 12, 9, 5, 2. Now I'm getting highest priority is what? 2. Correct? Now you can see the highest priority I'm getting is 2. Let us make this into what? Unsigned format. Now 2, reverse of the previous 2, 5, 8, 10, 12, 13, so on. Did you understand? These are two test cases. One test case is nothing but all the indexes I'm giving what? Same value, 0, 0, 1, 1, 2, 2. And the second test case is nothing but what? 0 I'm giving 15. For 1 I'm giving 14. 2 I'm giving 13. So on. Now this is how it is going to, it is making the what? prioritizing? Are you understanding?
Yes.
So let us take few other test cases of this in the next session. Okay. Today I request you to go through this. Go through this design file of this one. Understand the way how you are correlating or state diagram into the what? Program. Yeah. You understand this? Any questions are there? Let us take up in the next session. Okay. So other test cases we'll see in the next session. Now I request all of you to fill the attendance. Online student, I request you to fill the attendance. So let us start with other few test cases in the next session. Okay.